faculty development program on opportunity and challenges in modern power system, organized by Department of Electrical Engineering, Rajkir Engineering College, Kannauj. We are delighted to have such a wonderful group of academicians, researchers, and industry professionals joining us for this insightful event. Today, we have with us as a distinguished expert Dr. Omveer Singh. He has more than 18 years of experience in teaching as well as research and development. He completed his PhD degree in power system from FOET Jamia Millia Islamia, New Delhi. Currently, he is working as an assistant professor, senior scale in Department of Electrical Engineering, School of Engineering, Gautam Buddha University, Greater Noida. He is also serving as an additional director electrical in GP Gautam Buddha University. He is an active senior member of IEEE and Power Energy Society of Asia Pacific region. Also member company level in Consumer Grievance Redressal Forum, Noida Company Limited, Gautam Buddha Nagar. He has achieved Best Research Award for ITSR Foundation Award 2023. He is editor and co-editor of several journals like Journal of World's Electrical Engineering and Technology, International Journal of Emerging Advancement in Electronics and Electrical Engineering USA, Progress of Electrical and Electronic Engineering Journal etc. He is also providing voluntary service to several national and international publishing houses as a reviewer. He has published more than 120 research articles in peer-reviewed journals, reputed conferences, and book chapters. He has diversified research interests in the areas of power system, renewable energy, electric vehicle, and artificial intelligence. We will take a session on topic renewable energy system integration in automatic generation control of modern power system. I encourage all participants to actively engage and contribute to the discussion. Without further delay, I would like to invite Dr. Omveer Singh to share his experience and insight.
हेलो। हेलो। हेलो, आई एम ऑडिबल।
हाँ जी सर।
हाँ, ऑडिबल।
हाँ हाँ जी
ओके।
सर, आवाज आ रही।
ओके, आई एम जस्ट शेयरिंग माय स्क्रीन।
ओके।
माय स्क्रीन इज विजिबल।
हाँ जी सर। हमारी आवाज आ रही थी। हाँ, बीच में
हाँ, वॉइस
भाई इनकरेज के बाद।
क्लियर।
हाँ सर, लेट्स स्टार्ट द
मैं
सेशन।
स्क्रीन जो यस
हाँ
यस,
जी,
आई एम जस्ट
आ रही है।
शेयरिंग माय आई हैव शेयर्ड माय स्क्रीन विजिबल।
यस यस।
आई एम जस्ट बेसिकली डूइंग फुल स्क्रीन एक्चुअली में why it was not the full screen. Just wait 1 second. I'm just trying. I think my screen is visible. Actually, I'm not able to. mm,
Recording stopped.
Hello. Good morning to all. So I'm just audible. Hello.
Yes, sir, you are audible.
Hello. I'm just okay. Thank you. Thank you. So I'm just giving a mic talk on Professor Saul. Thank you, REC medical people and faculty members and the head of department. So thank you for giving me this opportunity to giving a talk on modern power systems, including renewable energy sources. So today I am just explaining this talk. So in this talk, I have just covered introduction and structure of power systems and electric loads, status of electricity generation, including renewable energy sources. After that, I have included a need of modern gate with the renewable energy sources. So what is the need? And I have also considered automation generator for sustainability and their reliability and the
Recording in progress.
so uh, basically, the power of electricity is basically flowing from the generating station to the consumer part. So the complete is known as the power system. So in the power system, we have several components like generating units, substations, transmission lines, and the distribution lines. So each every component has their duties. So generating plant's duty is to generate the electricity as per the requirement, and the substation's duty is to basically transfer the power from one level to the another and the transmission lines is basically carrying the power for the over the long distance, and the distribution lines this is for the providing supply to the consumers. So these are the components which are utilized to be supplied electricity for the consumer. So this is the basic structure. In the basic structure you have seen here, we are having generating station. Either it may be hydro, maybe thermal, maybe nuclear, any sort of a plant. The plant basically generating electricity as per the 11 kV or 25 kV appropriate voltage level. Then will it transfer further transmit by the high voltage transmission lines as per 220 kV. Then after that to the 220 kV supply is further subdivided parts. One is left side, right side. Then side we are providing this power to another receiving station. That is another receiving station takes this power at 33 kV from the 220 kV, and right
Sir, I think your screen is not sharing. Screen is visible now, sir. Kindly unmute your mic, sir. Your voice is not audible.
Hello, hello. I'm just joining the another device. So just wait for 1 minute, sir. Just wait for 1 minute. I'm just joining another device.
Okay, sir.
Just
Okay, sir.
joining
Okay,
the
sir.
another device
Okay, sir.
because it's creating problem. Okay. Hello.
Yes, sir.
So I just rejoin. Okay. So I my screen visible?
Yes, sir. Yes, sir.
Yes, sir. Visual, sir.
So this is the basic structure of the power system. At right side, we are providing supply to the consumer, and left side we are supplying the power for the big size of the consumer. Okay. Then So we have basically already explained, we are providing the major chunks of power from the power stations to the particular substation to the end of the consumer, either maybe big size of consumer or maybe small size of consumers. So any sort of consumer may be serviced by the service providers. So we can utilize any sort of fuel here, hydro, thermal, gas, nuclear, any sort of fuel we are utilize. So here we have transferred the power from the transmission line. Transmission lines may be HVDC or maybe EHV-DC. So high voltage DC transmission line or extra high voltage transmission line. In the modern days, we are having penetration or the inclusion of the renewable energy sources, so that the challenges of the power system engineering is increased due to the incorporation of the renewable energy sources. So we have to maintain our frequency at 50 hertz in our country, and basically in the Canada and other countries where they are serviced the frequency level. So this frequency level is basically we have to manage uh, because of the renewable energy sources disturbs the frequency levels. So we have to manage it by the help of the AGC. Then come for the electrical load. So we are having several types of the electrical loads: residential loads, commercial, industrial, government load, and municipal load, irrigation load, and traction load. So they are having different natures basically. The residential load, or you can say domestic load, we have they are covered the fans, lights, heaters, ACs, and etc., which are utilized by the normal consumers. Then commercial load. So commercial loads are basically shops, malls, restaurants. They have utilized the services from the suppliers in terms of the higher electricity rates as compared to the residential load consumers. So there is a difference between them. So then next one is the industrial load. So textile industries, chemical industry, automobile industry, and other industries load is basically also serviced by the service providers. So these type of loads basically take care about the power factors quality, so that they have to pay extra for the electricity supplier for maintaining the power factor. Okay, if they are maintaining the power their own side, then electricity department also providing some sort of the subsidies to them, so that's benefit they will get. Okay, then we will come for the government load. So government load basically defense factories, mining, PSUs, they are coming in the government load. Then municipal load, street lights, water pump, drainage systems, they are coming in the municipal load. And in irrigation loads, pump driven by motors, they are in the villages, in the village areas. Load basically comes in the irrigation load. So the rate of electricity is basically lower as compared to other loads. Then traction load, metros, railway system, they are comes in the traction load conditions. Okay, so these are the type of the electrical loads. We have to serve these loads as per their requirement, and according to the loads we have to plan the subsidy part, we have to plan the quality of power, we have to plan everything according to the types of loads. Next, I have just shown the electricity distribution network chart. So that chart is basically according to the January 2025 data that is prepared by the from the site of the CEA report accordingly, January 2025. Okay, so Central Electricity Authority report I have taken. Then according to it, I have prepared this chart. So in the chart, you can see here the grand total of total installed capacity of India in as per 31st January 2025. That is 466 gigawatt accordingly. Okay, so several types of the utilities or basically the fuels are utilized for generating the power. So that type of the plant is considered coal type plants, lignite, gas, diesel, nuclear, hydro, and renewable energy sources. Okay, so you can see here the first one is the coal. So we are generating the electricity 213 gigawatt electricity from the coal based thermal plant. Okay, so next one is basically lignite. Lignite based plant developed basically creates the electric generate the electricity 6.6 gigawatt. The next one is the gas. So gas based plant stored plants are basically having capacity 248 okay, sorry, 24 gigabyte. And next one is diesel. So diesel based units are having capacity that is zero point 0.6 gigawatt approximately. Then next one is the nuclear. So nuclear based plant is having capacity that is 8 gigawatt. The next one is hydro. Hydro's plant is capacity is 48 gigawatt. Then next one is the renewable energy sources based units having capacity, installed capacity is 165 gigawatt. So we can say the share of renewable energy sources based units are day by day increasing. Earlier days it was very lower, but nowadays it is the second largest energy producers in India after the thermal power plants. Okay, so overall generating units is installed capacity is 466 gigawatt in our country. Okay, so you can say India is the third largest energy producer and the consumer of electricity after China and United States. Okay, so utility electricity sector in India has one national grid. Okay, we are having five regions also with installed capacity is 466.25 gigawatt. Okay, so largest electricity installed capacity is basically with Gujarat 57.3 gigawatt. It is the highest power generating state. But last 3 years back, the Maharashtra was the highest installed capacity based state. Okay, in last years back. But nowadays, the Gujarat is the first one, largest installed capacity based state, 57.3 gigawatt. And the smallest capacity of its electricity generation is with Lakshadweep, 0.03 gigawatt. So this data is basically reflect that the highest installed capacity is with Gujarat in our country and lowest is with the Lakshadweep. Okay, so this is the energy distribution chart which shows the energy installed capacity in our country with the power station. Next, so I have just shown to your next chart. Next chart basically shows to the region wise total installed capacity of power station from thermal energy sources as per 31st January according. So northern region you can see that the installed capacity basically total thermal energy basically 66 gigawatt and western region capacity is 86 gigawatt and southern region capacity is 60 gigawatt and eastern region capacity is 28 gigawatt. Northern eastern region is 2.9 gigawatt. Okay, and Iceland based capacity is basically zero point 0.1 gigawatt. Okay, so this is the thermal energy sources which are installed in the regions. These regions shows that the highest generating capacity in thermal is with the western region, that is 86 gigawatt. Okay, and overall total generation of electricity in India through thermal energy sources, that is 246 gigawatt. Okay, so this is the chart of thermal energy. Next chart I have considered for the renewable energy sources as per 31st January. Okay, so in this chart you can see there the total renewable energy generation is basically 1212 gigawatt, and according to we have taken several regions also. Northern region capacity is 66 gigawatt and western region capacity is 65 gigawatt and southern region is 70 gigawatt and eastern region capacity is 7 gigawatt and northeastern region is 2.5 gigawatt and Iceland's capacity is 0.04 gigawatt. Okay, so this is the overall renewable energy sources generation capacity stations. That chart shows the installed capacity. Okay, then next one. So next is basically covers the overall energy sources capacities as per the MNRE. Okay, so you can see here this chart is also discussed earlier. So the installed capacity is coal, lignite, gas, which I have also considered earlier. Next, so the total generation in India, I have taken from comparison from 2010 to 25. That is the billion units. Billion units is near about the basically 1 billion unit is equal to 1 gigawatt basically. So this chart shows you In financial 2010 we are having 808 billion units total generation capacity, generated electricity, and after that 11 we are having 850, then 928, then in 13 969 gigawatt, or then uh, 120 1020, then it will increase day by day. So in financial 24, that is 1793 billion unit we have generated. Okay, or then 481, that is taken in this financial year 25, 481 till date. So we have considered the total generation in India, including renewable energy sources. Okay, earlier I have explained the installed capacity. This is the total generation generated power from these sources. Okay, then this is the growth rate in the generation in India from 2010 to 22 up to 22. So it will increase and decrease. It will change day by day. Earlier in 9 to 10, it was is what 7.15 the total growth rate of generation. Then in 10 to 11, 5.59, and 11 to 12, 9.14, in 12 to 13, 4.146, and it will take several levels. So you can see in the last in 20 and 21, it will end in minus 0.52. It means there is no addition of electricity stations in this year, or basically those who are installed, they have stopped due to the corona time. So that's why in this year, basically in this segment, the total growth rate is basically minus 0.52. Okay, in 21 to 22 it will further increased, that will be 7.96 from 21 to 22. So this is the growth rate in the India. Then the growth in solar power versus renewable energy generation, that is in the also megawatts. Okay, so this is the total renewable energy sources with respect to solar. So it's a shows you the contribution of solar energy in our country is higher with respect to the other type of the sources like wind energy, like biogas, like biomass, like mini hydro plants. So it is lower than the solar power capacity. So you can see here the overall in 2017 it was 14 gigawatt from solar, but in 24 it was in 90 gigawatt. It will increased, and overall growth rate you can see here in 17 it was 60 gigawatt, but at 24 it was 154 gigawatt. So it will increase a level from within 7 to 8 years. Huge changes in the generation. So growth rate of in the solar, or you can say renewable energy, very faster with respect to the other sources. Okay, then though this is the growth of generation of the renewable energy, that graph shows you the how the wind, how the solar, how the biomass, how biogas and small hydel and others and renewable energy total generation, how they will move the total generation ratio. This is the million units. Basically you can say that is 106 90 100 1698 means basically 106 10.698, that is approximately. Then it will move up and down, comes in the renewable sources from 20 to 25. So sometimes it will increase, sometimes it will decrease. So you can see from this graph also. Then this is the slide shows you the peculiarities of regional grids in India. So you can see here first is basically northern region. In the northern region, basically we have having the deficit region. You can see the electricity shortage here. We need to expand our generation level. Then this region is basically snow fed, runoff river hydro plants which units we are having. So this region having basically you can say uh, Himachal Pradesh, we are having Kashmir, we are having Uttarakhand. So these states are basically snow fed state, and they are also having the rivers in itself, so that we are having the capacity to generate the electricity these states are basically higher weather sensitive load conditions, and the load conditions also, and there these weathers are basically highly adverse in nature. We are having fog, we are having dust, we are having storms the regularly in the years. So that this is the very sensitive region. The next region we have covered, northeastern region, that there is a basically very low load. So load is of this state, northern eastern grid, basically low, very low, and it's having the capacity, high capacity to generate electricity from the hydro source, and the power transfer from northern eastern region to the other state eastern region, it's difficult. Evacuation problem we are having, so that we have to take over it. Then next region is eastern region. So in this region we are having low load region, and we are having high coal reserves because we are having Bihar and Jharkhand, we are states, so they are having the huge amount of coal reserves. So some plants are basically near to the coals. That why we can say pit head weight load plants we are having in this area. So pit head plant based load plants are these plants which are near to the units of the uh, coal coal units. Okay. Then western region. Western region we are having highly industrial area. So this is the industrial load is very high in this area. Then next one is the southern region. The load is very high and it is dependent on the monsoons. So hydro based systems is basically availability we are having. So we have to utilize that. This is the popularity chart with a regional way. Then next is the operating states of power system. So I'm audible. Hello, audible. Hello, I am audible.
Yes, sir, you are
Hello.
audible, sir.
Yes, sir.
Kindly continue.
Thank you. Thank you.
Yes, sir.
Okay. Okay. Thank you. Okay.
Audible.
So this is the chart operating states of the power system. So our power system is basically having five states: normal, alert, emergency, extremis, and zero storage state. First, we are our whenever our frequency and the voltage it's in the limited range, basically having the decided range. So at that moment, our running power system is known as normal state. Sometimes some issues are developed with the plants, so that state is known as alert state. So in this time the units shows the alarming states, alarming signals for the system. So it's the alarm, but at that moment the system is running in the normal range, voltage and frequency in the normal range, in the alert state. If we didn't take any precautionary measure or any certain sort of solution, so alert states comes in the emergency state. Emergency state means the systems comes in the dangerous mode. If we will not take care of the plant, then definitely plant goes to in the extremis state. Extremis state means the plant is totally disturbed, basically fault developed, and overall blackout done in the certain region. So that extremis state is basically very difficult state for the power operators. So extreme states can comes after directly from the alert state to extreme state, because suppose there is any thunderstorm, any issue, if it will not it will if it will persist for duration, then alert states will comes into the extreme state, means that the plant is failed. So if this is not done, then it will comes back to the normal state, the bidirectional flow between normal and the alert state. Then similarly alert to emergency state. Then you can see if the system comes in the extremis state, then no bidirectional flow. Then extremis states, definitely system goes to the restorative state. In the restorative state means plant should restart itself. So the all the operating conditions will reset again, and plant, this is the basically the loss retiming, so that the restorative time it will take. So it means basically the power outage operators have the loss, then plant take the times to restart. Sometime it will take hours, sometimes take it will minutes. So after restorative state, plants goes to maybe normal state or maybe alert state. if the issue persists with the system. So this is the state chart which shows the power system how to react itself. So I have told you the normal state, basically voltage frequency in the normal range. In the alert state, security levels basically falls certain limit, and the possibility the disturbance increases because of the weather condition. If the alert state basically persists for the longer duration, then it will comes in the transits into the emergency state. If emergency state, we will take the certain action, it will comes back to the alert state. Okay, then if we didn't take any certain solution or certain action, then alert state and emergency state goes to the extreme emergency state. In extreme disturbance, we have to take our system restart in the after this state, because in this state we didn't take any correct action, we are not taking following the correct guidelines, so that system comes in the extremist state. Okay, so it will happen. Why it will happen? Because the cascading outages and the shutdown of the major part of the power system might happen. What is cascading outages? Cascading outage means, suppose any one generator is failed, the neighboring generator will disturb due to the failure of the first one, and the next one will fail, then another next one will also fail. The series of failure of the components of the power system, motor, generators, transformers, due to the disturbance of the one component of the power system, so it will transfer to the other ones. So overall care of the systems, so that's why it's known as the cascading effect. Okay, so then come for the restoration state. Restoration state where transiting state limit, it will comes in the emergency, normal, and the alert state. So whenever plants will take restoration, then it will take time according to the size of the interrupted area. If the size of the interrupted area is lower, then it will take lower time, minimum time. If the size is higher, then it will take the higher time. So it will take restoration time maybe from minutes to the hours. Okay, so it will take again, if the restoration basically known as the black start. Basically black start, basically if any part of the system is basically restart to take the load conditions, that is known as the black start condition. After the restoration process, we have to reconnect all the generator, transmission line, and the loads for the normal condition. This is the operation of the power system, operation state. Then come for the time hierarchy of the power system. In the time hierarchy, you can see here, we are having first local control. We are the control problems. Local control is basically in the millisecond. So our relays, our voltage control and excitation control section functions it, and basically it will create control order for the units, so that local control works in the millisecond. Then come for the automatic generation control. Automatic generation control takes few seconds, 2 second, 5 second time. It's due what is function? It's duty to keep deviation in frequency power flow to be zero, because it's a disturbance. Change in power, change in the frequency. So if the change occurred, it means we have to take care, we have to minimize. This will be to zero. This error will be zero. Okay, for the certain set point of the plant, revert back to the set point. Set our plant at 50 hertz. So plant should be run on the 50 hertz. That is the duty of the AGC. Then comes the economic dispatch. Economic dispatch operation will take 5 to 10 minutes. Okay, its duty to overall cost of operation should be minimum. So it will minimize the overall cost of the operation. Okay, what on the basis of the base point and the participation factor for the units. Every unit participate in the process of the economic dispatch on their base points. What are the base points we have decided? It will work on it. Okay, then comes for the security analysis and control. Security analysis and control basically works few minutes to the hours. Okay, so it will take that it. So what is duty? Is duty to secure system operation with the respect to the security dispatch through generating shifting. Then unit commitment, it will take few hours to 1 week time. Its duty to, it will select the generating unit according to the demand. So best units it will take for the operation, other ones it will left it. So its final output we will take hourly generation and interchange scheduling. It's benefit for doing it. Then the system maintenance. System maintenance we will do annual basis. So regular maintenance of the system we have to do it for the system for the sake of the quality of power and the continuity of the power. Okay, if we will do it, then we will have the available network. Otherwise, our network will not be available for the as per requirement. Okay, this is the system maintenance part. Then the system planning. We have to plan our system yearly basis from 1 year to 10 years. So in that we have to modify our network, extend our network. We have to think over the development in the generation. We have to schedule the generating units in itself for the longer duration. So finally, we will get generation and the fuel management by help of the system planning. So these are the control problems in the power system. We have to do it according to the time scaling. These are they will work and give their output as per our requirements. Then I have explained earlier, our engineer's duty is to provide power in economical way, adequate and quality of power to the consumer of the urban as well as in the urban consumer of the urban as well as in the rural areas also, because they are also the rights to take quality of power. Okay, in order to achieve maintain basically all operating levels in the certain point we have decided, okay, by help of the control strategy. So AGC be automatic generation control basically the system basically it will adjust the power output of the multiple generators in our power system on the different units to maintain stable system frequency by responding to the fluctuation in the load, because load demand is also fluctuating basically, it will never steady. So that if the load demand is still changing, then frequency will disturb. Okay, so we have to balance our generation with consumption across the overall grid. So AGC duty is to maintain the power of multi-generators with respect to the load demand. Okay, so it will provide safe, secure, reliable, and economic operation. Okay, so that all the power systems, all the will work in the power pools. Power pools is the system in which we are having variety of power players, power stations. They will change and they are dealing the power. They are selling and purchasing the power for the sake of the consumers, for the providing the consumers quality of power. Okay, then next one. So what are the objectives? Objectives of the AGC are basically matching generation load demand at every moment. Okay. Then second objective is to adjust the frequency of the system, various bus voltage every instance at the scheduled nominal value. What is the nominal value? Then we have to manage the voltage level, the frequency, both parameters it will match as per the set point. What are the set point? It will match. Then power system basically divided into several areas. In the several areas, they are having tie lines, power exchange to the scheduled values. Tie line is the line power which is connect. These are transmission lines. Whenever transmission lines are connected in the power stations, these transmission line is known as tie line. Otherwise, these are known as the transmission line. So power exchange we are doing by help of the tie line between the power plants as per their area requirement. Suppose if one requirement increased, then it will not able to provide the certain amount of power to their own area, then next area will support and generate the electricity and transmit this power by help of the tie line to the first one area. So first one area having, or you can say borrow the power from the neighboring area, then both area works and supply the power for the area one's consumers if the demand is increased. So the demand of the consumer is satisfied by the both units. So this is the, you can say, power system networks exchange program of power by help of the AGC. So within each area, sharing of generator units to meet load demand of the system in the most economic fashion. So we have to provide a supply in a cost effective manner. if the cost we can manage, then definitely we can takes our consumer for the longer duration. Otherwise, our consumer will shift to the other power supplier. So we have to manage our consumer for the longer duration in our system. Okay. Then the what are the importance of the AGC? So AGC basically maintains grid reliability and the efficiency. So reliability of the grids will be maintained by help of the AGC and their efficiency also. Suppose if grid is having grid load is increased, if we are not having AGC, then what happened? The particular grid area, any grid area will fails to take the supply. Okay, because the increment in the load in area, any one of the area. So AGC will manage this power discrepancy. So AGC will maintain grid reliability and their efficiency also. Second importance is that balances supply and the demand in real time. So AGC works in real time. It will balance supply and the demand of the consumer. Then that prevents blackout and enhances power quality. So blackouts and enhances the power quality means the you have basically remember that in 2012, July 2012, there was a power blackout in the northern Greece because we are not having that time AGC. If we are having AGC on that time 2012, then there will be no blackout in the northern Greece in India. So we have take care. We have utilized AGC and implement AGC in NTPC Dadri, that is in Uttar Pradesh. So we have utilized the pilot project. Then this in this we have managed the thermal units for that. So now this AGC basically implemented in our country, most of the places. So that's why we have we can take care of our overall power system from the blackouts due to the unwanted load, due to the unknown conditions. So it will enhances the power quality in terms of that. Okay, so these are the importance of the AGC. Then the AGC basically divided into the two parts, basically frequency and the voltage control also. So if we will into, you can see this is the basically right side, you can see a image. This image shows you the left side load, then right side we are having generator. Okay, we are having this scale basically showing if is have increased, then generation will decrease with respect to, which means the power will not compensate to the load demand. If the load demand will not compensated by the power, then definitely a disturbance developed in the overall system. So we have to maintain our power, we have to maintain our frequency to regulate tie line power flow. Okay, if there is no discrepancy in the power, tie line power flow is basically zero, no power exchange between the plants. If the plants will take care their own loads, then there is no need to transfer from power one plant to another to the first one. There is no need to shifting of the power. Okay, and this can be possible if frequency is constant, because frequency is directly interacts with the load. If load is increased, then frequency is disturbed, basically decreased, and we have to maintain frequency at the 50 hertz. Okay, because most of the component depend on it. Then next, the suppose the frequency is low, then what are the issues with the systems? If the quality of power to station auxiliaries, poor quality of power, if the low frequency, what are the effects? Reduced output of the auxiliaries will reduced, maybe motors, maybe other components, and loss of generation capacity also done due to this shortage, this issue. Then second effect of low frequency, induction motor speed will drop, and after that you can see the output torque reduced, the efficiency of the induction motor. Then third one, what are the effect of third? Saturation of inductive equipment like transformer, induction motor, they will saturate. Then what is the effect? The increase of magnetizing current at very low power factor, and it will increase the reactive power requirement. Reactive power requirement will increase. under voltage conditions also developed, increased core losses due to harmonic currents, and it will also reduce equipment's capacity also. Then vibrations in the turbines also. Turbines having the vibration itself because the speed is down, frequency is down. So frequency is directly proportionate to the speed of the turbine. Omega equal to W 2 pi f. You can know that. So frequency down, it means speed of the turbine will down. If the turbine will down, so there will be a vibration. So turbine blades may get damaged due to this issue. Next, then if frequency is high, then what happened? Vibration of the turbine also started because the frequency is high. Then there will be speed of the turbine is increased as per their standard. But due to this one, turbine blades get damaged due to this issue. Okay, then based off the fuel. Otherwise, if we are having high frequency, it means turbine speed higher, turbine speed higher, it means input of the turbine will be higher, means fuel will be taken by the turbine will be higher. If it will be coal based plant, or maybe it will be hydro, or maybe nuclear, or maybe gas, so these turbines will take more fuel for moving their parts, so that it's a totally wastage of the fuel. So ultimately it's a loss to the utility. So utility should having the losses due to this high frequency. These are the losses due to the low and the high frequency. So frequency should not be low, not be high, it should be maintained at the 50 hertz level. Okay, then automatic generation control basically achieved there in itself. Frequency should be in between 49.8 hertz to 50.2 hertz as per Indian Electricity Grid Code. So it should be in between it. Otherwise, AGC will be activate. If the frequency will goes down below 49.8, if the frequency will moves upward 52.2, so the frequency should be lie in between this range. Okay. Then secondly, the reactive power can be achieved by controlling the excitation, that is known as automatic voltage regulation. So automatic voltage regulation will be allowed, will be permissible up to the 220 kV line. It will plus minus 10%. If it is in the distribution level, so that will be plus minus 6%. Okay, so that is the tolerable limit. So it can be utilized. Okay. So the combination of LFC and automatic voltage regulator is known as the AGC. So frequency range should be lie between 49.8 to 50.2, and the voltage of the transmission can be vary up to plus minus 10% up to 220 kV. If the voltage level is more than 220 kV, then this limit is plus minus 5%. You can vary. If the voltage in the distribution level, this will be plus minus 6%. This is the permissible limits as per the Indian Electricity Grid Code. Then that is AGC scheme. So you can see here basically we are having two loops, load frequency control loop and the voltage regulator loop, left side LFC loop, right side AVR loop. So both loops makes the AGC scheme. Okay. So the right side you can say tie line power is change in the tie line power enters in controller. So this controller basically gives the change in power in the valve control mechanism. So valve of the system basically you can say speed governing valve, that is prior the turbine, that will allow the input to the steam turbine or maybe the hydro turbine. So if the frequency goes down, it will require more power in the turbine, more kinetic energy in the turbine. So this kinetic energy comes from the valve control mechanism. So valve control mechanism will be open more and allow the permissible flow to maintain the frequency at 50 hertz by help of the turbine. This turbine is basically providing the rotatory power, change in power to the generator, and generator will provide the frequency, and there will be connected a frequency sensor. Frequency sensor will sense the frequency, it will in the limited range or not. If there is a change in the frequency, then it will change the signal to the controller. Controller takes the decision according to the change in the frequency, and according to this change frequency signal, the tie line will power will be increased or decreased. Suppose the frequency change is higher, then change in tie line will be higher due to the interchange, because the one plant support to the another more due to this region. So in the right side we are having automatic voltage control loop. There is a voltage controller loop. So voltage control loop here having connected a control excitation system. This control excitation system should take the signal in the reactive power, change in the reactive power from the controller. This controller sends the signal to the exciter. The reactive power flow should be required high or should be low as per the voltage. Suppose the voltage level goes down, then it will require the higher level. Okay, higher level of the excitation, so that the change in the voltage will be decided by the comparator. Comparator compares the set value of the voltage with the change in the voltage. So the scheduled value of the voltage minus actual value of the voltage, this will make a change in voltage. So change in voltage goes to the controller. Controller take the decision according to the change in voltage. If the change in voltage is higher, then the reactive power input to the controller excitation should be higher, and this higher excitation should increase the terminal voltage of the generator, and this terminal voltage is compared to the voltage sensor, and voltage sensor compared it, and according to the compared, it will pass the comparing signal to the comparator. If there is no change, then there is no signal to pass to the comparator. So the generator outputs compared by frequency sensor and the voltage sensor. These two sensors will decide. There will change in frequency, there will change in voltage. If there is no change in voltage and frequency, then in no operation will be taken by the AGC scheme. Okay. Then what are the basic components? Basic component of AGC: primary control, secondary controller, economic dispatch. Okay. So primary controller basically duty is to, it will take a direct action whenever sudden change in the load. Okay. So reaction to the frequency change. Secondary controller will work whenever tie line flows to be scheduled. So there will be control actions done by the operator. So operator will intimate to the particular plants that you have to increase the generation, you have to provide your reserve power to your neighboring plant. So neighboring plant will take care himself itself by the change in frequency, by change in the load their own area. So its change will be take care by the support of the neighboring plant. So that is the function of the secondary control. Then the economic dispatch. Economic dispatch is the system in which it will decide which plant should participate to provide the power for the disturbed area. So disturbed plant will take from the particular plant which one is near to that plant because of the cost of the electricity, so that they will support in an economic way. So this is economic dispatch. So this is the frequency division associated I have explained earlier. Okay, this is the control mechanism of the power system. So in this you can see steam or water is basically flow in the governor valve, in the gate. So the turbine speed will depend on the flow of the steam, which is comes to the steam valve. So mechanical torque will develop according to it. If it will higher input inlet pressure of the turbine is higher, then the mechanical torque is higher, then mechanical power will be higher with respect to is, then the torque, electrical torque will be higher with respect to generator, then generated power will be higher as per the level. Then electrical load will be take care by this generation. Then there will be a loop is also connected, speed governor loop. The speed governor loop compares the speed of the governor with respect to the generated power. Okay, to the generator. So the mechanical torque is compared. As per the compare, it will provide the valve to signal then what action should be taken by the system, and valve will be activated according to it. Then AGC with the secondary control. In the secondary control, we have utilized basically you can see here a single area with connected to the secondary generating unit. So we are having first block, we are having governor. So governor duty is to pass the input fuel to the turbine, steam or hydro or whatever the input, and turbine will activate according to the governor action. Then this will come to the summer point, and this will also take care the disturbance. Del PL is the disturbance, change in the disturbance, and the change in the disturbance will show the change in the frequency. Then according to the change in the load demand is changed, then the change in the frequency comes. So this will comes back, it will comes back to the loop from the regulating parameter. The regulating parameters will regulate the this change in frequency. Then after that, the dotted line comes basically connected to it. This is the integral controller. This is the negative sign minus ki upon a, because so this will provide the gains signal physical controls according to the change in the frequency. So both units, primary and secondary units, both units will be controlled by these controllers. So controllers will send the signal for the operation, for making the smooth operation of the plants. This is the secondary controller. Then AGC for single area. First, we have to model system. Then we consider the single generator, or we can connect the multi generators. So in this case, we have considered the three generator case. We have considered this is the simplified control model. So in that we have utilized the group of generators in that, and consider the area of one generator is single area, and we have considered the tie line between area as the transmission line connecting the buses to the single area. So we can apply the same analysis to the multi area. We can analyze, we can use one area, two area, three area, or multi area model. We can do it by help of the control management. Okay, so we have to come with the frequency power characteristics in the each area. So this is the powerful management. Then come for the transmission network systems. So the generation of bulk power at remote locations. So we have to utilize the electric transmission network. Electric transmission network may be HVDC, maybe HVAC, as per the requirement. If the transmission line is for long distance, then the preferred transmission line is HVDC transmission line for the long distance, because the losses. So we are having low minimum losses in the HVDC. If we plan AC transmission line for the longer distance, the losses will be higher. ISPA losses will be higher. So that we will prefer HVDC transmission link. So culture and Kolar transmission link is basically East Thousand transmission link. The distance of this link basically 1450 kilometer length. So this is the transmission line of HVDC, and it will provide the power 500 kV power, HVDC power. It will transmit it by, it will govern by PGCI, Power Grid Corporation of India Limited. It will govern it. So 1450 kV that will provide it. So at the 500 kV HVDC transmission line. Then what are the advantage of transmission line? You can see in the system, it is economical, and it is astronomical in interconnections, because there is no requirement of the maintaining the frequency in the HVDC transmission line. And power flow control is better as per the HVAC. So what benefits will also, that there is a stability of the DC is better than the AC. Then the many applications you can utilize HVDC parallel with the EHVAC transmission line for the benefits. We have utilized one line HVDC, one line EHVAC between the plants, so that we can take the benefit from the both sides for maintaining the power. Then operation of interconnected power system. So operation, in the operation, ability to sell and exchange power over the interconnection. So we can sell and exchange the power from one plant to the another to the first one, that we can say, can do it. So then second point is increased reliability, that results being able to depend upon the one's neighbor. Due to this, one neighbor support to the another one, this increase the reliability system, because if any system is having, any area of the power system is having disturbance in on itself, the हेलो, मैं दोबारा शेयर कर रहा हूँ इसको। आई एम जस्ट शेयरिंग अगेन। हेलो।
Yes, sir.
हेलो। हाँ, ठीक है। तो वी हैव टू बेसिकली शेयर द रेस्पॉन्सिबिलिटी between the areas so that maintain the frequency within acceptable limits. That is the benefits of the operation of the interconnected systems. Or we can transmit the power from the larger chunks of the power from the plants to the load centers also. And it's another benefits we can construction. We can construct the larger size of the units in an economical way. This is the main benefits of the operating the power system in interactive manner. It will also provide the flexibility to unexpected emergency loads condition. It will provide also the seasonal exchange of power between areas having opposite requirements. So suppose in the summer time we are having issue about the water. So in that time we can generate electricity from the solar farms better way to provide the supply in terms of the hydro. So that flexibility we are having in the power system network, or we can provide the supply from the other units also, like wind farms also in the summer time. So this flexibility we are having in the unexpected load conditions also, and we can utilize storage systems also for supporting this type of unexpected emergency conditions. So this is the benefit. This is the transfunction model of the systems. Okay. Then modern power system network. So modern power system nowadays it is going to smarter day by day. So we have to organize our system, generating system, transmission system, distribution, customer participation using demand side management so that customer participation comes. Then operations should be online. Basically, we are doing nowadays. Our market is basically also online. We can sell and buy electricity in the market in an online way, and variety of service provider we are having due to this modern time. Then benefit of that modern system is that it's a basically smart, best optimal utilization of all available sources. We have a plan to manage all the things. So all the things are interconnected. Generators, service provider, markets, bulk generation, transmission, distribution, customers, all are interconnected. So all are having equal information at before the time of operation. So anyone can take the decision for the right time. That is the benefit of the modern power system network. So modern power system network is basically as per definition of the Nation Institute of Standards and Technology USA. So a modernized grid that enables bidirectional flow of energy and uses two-way communication control capabilities that will lead to an array of new functionality and application. So in the smart or basically modern grid, we can transfer the information from plant to the consumer to the service provider. वो all are interconnected, so both way communications and control works will be done in these functionaries. That is the benefits. Okay. Then if we compare with the conventional power grid to this modern power grid, you can see it as per architecture wise. Earlier, conventional power grid is basically in the vertical nature. First, generator, then transformer, then transmission line, then substations, then distribution stations, and then there is a systematic manner. Basically, source is the top position, consumer is the lower position in the conventional power grid. But nowadays, all are in the distributed structure. Consumer is also generating electricity by their own source, and it will take the supply and it will provide the supply to the grid. So unbundling and distributed structure nowadays. Secondly, consumer participation. Earlier, there is no participation of the consumer and consumer are uninformed. But nowadays, consumer is informed and participated in nature. So you can see by the telemetering also. the suppose one person is having a 5 kilowatt generating setup their solar rooftop, so it will take the supply from the grid and it will provide the supply from the grid as per the generation and the demand their own self. That is the beauty of the modern power grid. Okay, then next point is generation and storage option. Central generator dominance, okay, and no storage framework. But nowadays we are having distributed energy resources, so we are having benefit. Then poor quality of power in conventional grid, then no focus on outage and quality. But nowadays we are having quality of power, limited customer focus, but better customer focus. Nowadays we are having better data management, better prediction management, but earlier we are not having no management of data, poor management. Nowadays we are not having self-healing system, but nowadays earlier we are not having, but nowadays we are having self-admit healing system, automatic and predictive fault system we are having. So modern system is having number of benefits with respect to the conventional power grid. So this is the modern grid network. You can see here there is a bidirectional information between the consumer and the sources, but in the convention there is no movement. So dark blue line arrows show to the power flow in the smart grid, and light blue line shows the conventional power grid network. It is the unidirectional flow in the conventional, or in the bidirectional. In the smart grid there is a bidirectional flow between the system, you can see. Or in the smart grid or modern power system, we are having interactive intelligent information communication system network in itself, you can see here. So there is energy storage system also bidirectional in the smart system. Okay, so this is the beauty of the modern grid network. This is the transformer structure. You can see earlier I have told you basic structure. Earlier we are not having a not having basically solar farm, not having wind units, not having basically other renewable sources or other small type of the generation. But nowadays we are having smart generation. Basically, consumer can also supply, consumer can also take the supply from the grid. That is the beauty of the transform structure of the power system. So that is the beauty. Then what is the role of the AGC in power system reliability? So it will increase the stability of the power system in the variable load condition. It will also preventing blackout, improving resilience. That is the benefit. Then it will improve the coordination between the multiple generating units. That is the beauty of the power system. So sustainability challenges, integration of renewable energy sources will integrate in the system, that will increase the sustainability of the system. Basically it will be a challenge to the system. So variability and uncertainty in the generation in the renewable sources, that's why it's a challenge. The need of real-time control mechanism in the inclusion of the REs, renewable energy sources. So sustainability challenge in the modern power grid systems. Then AGC and sustainable power system. How AGC helps balance the renewable energy fluctuations, that is the challenge. Then smart grid and AGC implementation for energy efficiency, we have to do it, and some case studies with the renewable rich grids we have to also discuss. So AGC scheme based on model control concept. Comes to conventional AGC scheme, proportional, integral, PID. These are the conventional schemes of AGC. Optimal AGC schemes basically first developed by Elgard and Fosha. Then it will consider the all states of the system. Then soft computing technique, AI technique, machine learning, fuzzy algorithm, all are the modern techniques for the AGC scheme. This is the function diagram. So following conclusion have been drawn from the my presentation. So AGC will be benefited for the modern power system. So modern power system cannot be work without AGC. AGC modernize it because it is a control over the frequency with respect to the load conditions. So it will take the decision on right time. Okay. And second point, AI and machine learning in AGC. basically very useful. And then demand side management and AGC synergy is also there. What is AGC synergy? AGC synergy means basically the power players will work together for making power generation and providing the service to the consumer. That is the AGC synergy, and they both were worked on it. And demand side management, basically consumer will participate with the grid, and grid will take the response of the consumer. Then story in the energy optimization, AGC optimization, we can utilize the energy storage system with the power systems so that AGC should be optimally work for this benefit. So at a point, it can be a better idea to solve AGC problem or a power system rather than conventional. So my talk basically shows that the modern power systems should be able to handle real-time issues with the help of the AGCs in terms of frequency, in terms of the voltage. So the basic parameters will be taken care by the AGC. Okay. So thank you. My talk is over. Any doubt? If anyone having, so please question. If anyone, thank you from my side. Hello, I am audible. Hello, I am audible.
Yes, sir, audible.
My side is over. Welcome for questions. If any question. So I think there is no question, so I should leave because I have lecture also. Hello.
Yeah, sure.
Hello,
Sir.
yes, sir.
If
Thank you
you
so
have-
much, sir.
May I leave?
Sure, sir. Thank you for the session.
Thank you. Thank you, Abhishek. Thank you. If anyone having questions, so you can email me. My email is available, Dr. Kamlesh. So Dr. Kamlesh can provide you. So you can send there any research related issue, any other issues about AGC and modern power system. So you can talk to me by mail. I will definitely provide you the solution or support you. So thank you everybody for listening me with patience. Thank you.
Thank you. Sure, sir.
Thank you.